The orbits of these 3 planets take 6, 9, and 12 days respectively to circulate around the small star. For clarity and definition, planets outside of our solar system are defined by the term exoplanet. This recently discovered solar system is unique because no other system that we know contains so many Earth-sized exoplanets. So the question is, how did NASA do it? Astronomers used the Spitzer Space Telescope to make the discovery. This telescope looks at infrared wavelengths which glow from the TRAPPIST-1 star and can detect when a planet passes in front of it. The telescope is able to detect this because the glow from the star gets a tiny bit dimmer each time a planet crosses in front of its path. From this data, they could estimate the mass and density of these planets. In total, the Spitzer spacecraft monitored the solar system for about 500 hours. Traditionally, in the 20th century, exoplanets were originally found by the wobble that they induced on a star as their gravitational pull affected it. This method only just allowed us to know that these planets existed. For a visual example, check out the wobble of the star on the left in this artist's representation. Nowadays, in the 21st century, we can analyze in much more detail. Here's how it's done. When light from a star passes through the atmospheric horizon of a planet and travels trillions of kilometers to us, that light is affected by gases in the alien planet's atmosphere. The different wavelengths of light are absorbed by different gases. By analyzing the light spectrum, we can actually gain insight into the chemical composition and likely makeup of that atmosphere. That's not bad for being trillions of kilometers away. Now, the funny thing about all of this is that the Spitzer telescope, which was launched back in 2003, was never supposed to be operational for this long. The craft wasn't even planned to do any of this. So how does the Spitzer telescope actually communicate back with scientists on Earth? The telescope actually follows the orbit of the Earth, but at a slightly slower speed. As the craft gets further away from us, its antenna has to point at increasingly higher angles to communicate with us. Unfortunately, at the same time, this higher angle of tilt results in less sunlight reaching the solar panels of the craft. This means that there's less power to the telescope, so eventually we're going to lose communication with the craft because it would lose power completely. But this isn't the end of things though. In 2018, NASA will be launching the James Webb Telescope. This is a massive leap forward in all previous efforts, and from this telescope, we'll actually be able to see images of these distant planets. Part of the Spitzer's extended mission is to scout out new areas for the James Webb Telescope to look at in more detail. It's kind of like passing on the baton between 2 telescopes. One final point of interest that you might like to know is that, believe it or not, exoplanet hunting is actually very recent. The first exoplanet was discovered in 1995, and its name was 51 Pegasi b. This planet was a hot, unkind place, very close to its parent star and about half the size of Jupiter. Since then, thousands of exoplanets have been found. This isn't really a testament to how smart we've gotten over the past quarter century, but it's more a measure of how our technology has improved, allowing us to be able to detect more planets. It doesn't stop there though. Recent statistical estimates say that there's at least 1 planet around every star in our galaxy. That's something like 1 trillion exoplanets in our galaxy alone. Many of these are Earth-sized. And I find this fascinating. All in all, it kind of makes you feel small in a way. Pretty much every part of world history, every person you've ever heard about or known, and all things relative to us throughout time have just happened on this tiny planet, which is a microscopic part of a much bigger picture. Anyways, that was just a quick video highlighting NASA's latest discovery. I hope you found that interesting and learned something from that. If you've just stumbled across this channel, feel free to subscribe. This has been Dagogo, you've been watching Cold Fusion. Thanks for watching, and I'll catch you again soon for the next video. Cheers, have a good one.
Cold Fusion. It's new thinking.